OSI model. The most common model that depicts communication over a network is the OSI model. The OSI model divides network communication into 7 layers: physical, data link, network, transport, session, presentation, and application. The OSI model only represents what happens theoretically between communicating computers on a network. It does not specify what hardware or software should be supported at each layer. Lessons covered in this video: OSI model and associated function. In the early days, when computers were first connected using a network, sharing of resources was the primary objective. To perform this, International Standards Organization wanted to design a standard model. This model can then help the vendors to create the other interpretable devices. As a result of this, OSI reference model was released in 1984. The OSI reference model describes how the data is transmitted from the application layer of the sender's computer to the application layer of the receiver's computer. Each layer of the OSI model is described in details in this lesson. Topic covered in this video are: Open System Interconnection Reference Model. The Open System Interconnection Model defines a networking framework for implementing protocols in 7 layers developed by the International Standards Organization. This model is called ISO OSI reference model because it deals with connecting open systems for communication with other systems. The OSI model is an architecture which divides network communication into 7 layers. Each layer covers different network activities, equipments, or protocols and has its own functions. A new layer is created when different functions are introduced. The protocols help the other systems to communicate with each other so as to utilize the functions provided by those layers. There must be a minimum number of layers so that the complexity of the model can be reduced. The data can then be transmitted between interfaces easily. Two or more functions should not be integrated to a single layer. Hence, the OSI model is designed to have 7 layers. The purpose of the OSI model: it breaks the network communication into simpler parts that are easier to develop. It allows different types of network hardware and software to communicate with each other. It prevents the changes in one layer from affecting the other layers so that they can develop more quickly. A brief review of the OSI model. The Open Systems Interconnect model is a layered approach to networking. It has 7 layers which has the following order: application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. Layer 7, application layer. The application layer is the entrance point that programs use to access the OSI model and utilize network resources. It is responsible for interacting with the actual user application and is responsible for providing application services such as file transfer, email, and network services. It includes network software which directly serves the user with the user interface and application features. It is used when one machine starts communicating with another. Application layer interact with the application software and represent the service that supports user application and establishes user interface to the network service. This layer is usually made available by using an application programmer interface. Some of the common application layer protocols are HTTP, FTP, SMTP, and Telnet. The application layer performs a variety of common functions like it provides network services directly to applications, determining the resource availability of intended communication, synchronizing communication, authentication of intended communication partners, and data transmission. Layer 6 Presentation Layer. The presentation layer is one of the simplest layers which modifies and translates the data to ensure that it is presented appropriately for the end of user. The presentation layer has major functions. They are data conversion. The sending device can convert text or data into general format, American Standard Code for information interchange, for transmission over a network. The receiving computer converts this format to a format required by the destination application. It translates the data from a format from the application layer into an intermediate format. Data compression reduces the number of bits that need to be transmitted on the network. Data encryption. Data is converted into encoded form which cannot be read by unauthorized person. It encrypts the data for security purposes. Layer 5 Session Layer. The session layer primarily starts at the beginning and end of a transmission. At the beginning of the transmission, it makes known its intent to transmit. At the end of the transmission, the session layer determines the successful transmission. This layer allows session establishment, maintenance, and termination between processes running on different stations. The session layer has some of the protocols which are implemented. They are network file transfer, structure query language, remote procedure call, and AppleTalk session protocol. Layer 4 Transport Layer. The transport layer provides the upper layers with a communication channel to the network. This layer collects and reassembles any packets, organizing the segment for delivery and ensuring the consistency of data delivery by detecting and attempting to rectify the problems that are created. The transport layer ensures that the messages are delivered error-free, in sequence and with no losses or duplications. The transport layer decides the type of service to be provided to the session layer and establishes connection across the network. Transport layer protocol is generally categorized into connection-oriented and connection-less protocol. Connection-oriented. The connection-oriented communication is a process which involves establishing a connection between the two hosts. It transmits the data through the devices at the endpoints which uses protocol to establish connection before sending the data. Transmission Control Protocol is a connection-oriented protocol. The 4 steps in connection-oriented communications are as follows. It establishes connection between the sending and receiving station. Synchronization. When connection between the two devices is complete, transfer of information begins. It sends the data packet to the destination station and lets the other end of the station to know the data is receiving. The destination station then sends the data packet back to the source to let the source know that it received a notification message. The sender will always be notified of the data packet's failed delivery. two devices communicate with each other and ensure that packets are delivered error-free in sequence with no losses or duplications. Connection-less protocol. In the connection-less communication, no initial connection is established between the two endpoints. The device transmits the data from one end to the other and without ensuring that the recipient is prepared to receive the data. Internet Protocol and User Datagram Protocol are connection-less protocol. Function of transport layer. Flow control. Flow control is a method of controlling the rate at which the device sends data. The flow control has three standard flavors. They are buffering, congestion notification, and windowing. Buffering. Buffering is one of the simplest methods used in conjunction with the other methods of flow control. The input buffer usually can hold enough data packets, but sometimes the data flow at faster rate than the receiving device can process it. Congestion notification. This is a signaling technique used by data transmission systems in order to indicate the status of network congestion. Devices that are communicating data across a network rely on congestion notification to decide when to send or delay the transmission of data packets. Windowing. Windowing is a technique used to deliver the data packets to the recipient in the same order in which they were transmitted to have a consistent connection-oriented data transfer. Layer 3 Network Layer. Network layer is one of the layers in OSI model that define how internetworks or interconnected network function. Network layer added header containing logical address of the device. Network layer is concerned with getting data from one computer to another computer even if it is on a remote network. The main purpose of a network layer is to decide which physical path the information should follow from its source to its destination. The network layer provides functional and procedural means of transferring data from source to destination over one or more networks. Two important aspects required to send the data from one device to another are logical address related source and destination, path through which the data has to be sent to reach the destination. The important functions of network layer are routing and forwarding data. It is concerned with physical and logical addressing of device, error detection, flow control, segmentation and sequencing of data. Internet Protocol handles physical and logical addressing of workstation. Functions of network layer. Logical addressing. Network layer is also responsible for logical addressing. It is also known as network addressing or layer 3 addressing. Routing. The main function of the network layer is to move the data packets through a series of devices in a network. Fragmentation. The network layer has to send message to the data link layer for transmission, but the data link layer has limits on the length that can be sent from the network layer. Error handling. The network layer also includes error detection and recovery. Layer 2 Data link layer. Data link layer is concerned with unique identification of each device and provides physical means of data transfer. If data link layer provides a system through which network devices can share the communication channel, this function is called media access control. It also provides error-free transfer of data frame from one node to another over the physical layer, allowing the layers above it to assume almost error-free transmission over the link. The data link layer is mainly divided into two sublayers, logical link layer and media access control. Logical link layer. The logical link layer manages the communication between devices over a single link of a network and enables multiple higher layer protocol to share a single physical data link. Media access layer. Media access layer manage protocol access to the physical network medium and determine the hardware addresses. Data link layer mainly deal with the following aspects: arbitration, physical addressing, error detection, and data framing. Arbitration. Arbitration is the method to access a single data channel when multiple hosts are using simultaneously. Physical addressing. The physical address is designed to uniquely identify the devices. It is the required component to transfer the data packets from one end to the other end of the device, specified with the appropriate physical addresses. Error detection. Data link layer determines the error problem which occurred during the transmission of data, introducing a trailer called FCS which detects the error before it sends the data packet to the remote machine does it. FCS uses a cyclic redundancy check is often used to allow the station receiving data to detect if it was received correctly. Data framing. The data link layers of both the machines must be using the same frame types so that the data packet will recognize the actual data contents. Layer 1, Physical layer. The physical layer is the lowest layer of the OSI model and is concerned with the transmission and reception of the unstructured raw bit stream over a physical medium. It describes the electrical, optical, mechanical, and functional interfaces to the physical medium and carries the signal for all of the higher layer. The physical layer is the most basic network layer, providing only the means of transmitting raw bits. Some of the function of physical layer involves modification of data into simple digital signal pattern as ones and zeros, transmission of raw bit stream over physical cable, establishment and termination of connection to communication medium such as cables. Communication resources are effectively shared among multiple users. Conversion of digital data and signal to transmit over network. The following table describes the different ways, the different layers and its functions operating in the corresponding layers. Application layer. Interface between the user and the application. Provides services that support user application like email, file transfer, etc. Provides application programming interface. Presentation layer. The presentation layer is concerned with the syntax and semantics of the information transmitted, encoding data in a standard agreed upon way. Data compression and encryption work in this layer, responsible for protocol convergence. Session layer handles remote procedure calls, establishes and maintains connection, provides synchronization between communicating computers, provides token management and dialog control. Transport layer ensures error-free delivery of packets, prevents duplication and omission of packets, flow control. TCP/SPX provides connection-oriented service and safe delivery of packets. UDP provides connection-less service and safe delivery of packets is not ensured. Network layer. Conversion of logical address into physical address. Routing of packets is carried out by this layer. Error reporting regarding packet delivery, it determines the best route. Data link layer controls flow of data, performs error checking, organize data into logical frames. The hardware address is resolved here, communicates through switches, bridges and intelligent hubs. Physical layer Signals are transmitted and bits are represented. Determine the cards, cables used for transmission. Defines the electrical and the mechanical interfaces available for data transfer. Communicate through hub, switch, cables, connectors. The data conversion in each layer takes place as follows. The data is created in the application, presentation and session layers from the user's input. The transport layer converts the data into segment. The network layer converts the segments into packets or datagrams. The data link layer converts the packets into frames. The physical layer converts the frames into bits. The Open System Interconnection model defines a networking framework for implementing protocols in 7 layers, which is developed by the International Standard Organization. The OSI model has a layered architecture which divides network communication into 7 layers. The OSI reference model has 7 layers which has the following order: application, presentation, session, transport, network, data link, physical. The major functions of network layer are logical addressing, routing, fragmentation and error handling. Data link layer is mainly divided into 2 sublayers, logical link layer and media access control. Thank you for watching this video.